In this video, we want to compile the solution set for Stat 204, that's Statistics for Biological and Agricultural Sciences. It's also advisable for physical science students to also watch this video and learn from it because it is the same syllabus. What I mean by physical science is the Department of Physics, Chemistry, Computer Science, and Engineering, and then okay, so let's start. The first question is, state the conditions for using the z-test statistic in a statistical hypothesis testing. Now, the conditions for us to use the z-test is that the first one is that sample size n must be large. The second condition is that population variance sigma squared must be known. The third one is that population must be known to be normally distributed. These three conditions are the condition to use the z-test in a hypothesis testing. The number 1b says, in completion times in seconds in a biological experiment recorded by 15 different students are these values. Determine a 95% confidence interval for the mean completion time, mu naught, of the experiment for students. The first thing we would do is to write out those values given to us. I will need to pause the video because of time and write out the values given to us for that experiment. So these are the values given to us from that experiment. The reason for this table is because the formula for us to get the 95% confidence interval is x bar plus or minus t 0.05. The reason for 0.005, the reason for t is because they are just 15, so the sample size n is little because 15. When sample size is large, it means that sample size is from 30 and above, so we say it is large. So, but for when it is less than 30, it is small, and we'll use t-test. So t 0.005, that's 95% confidence interval, into n minus 1, that's degree of freedom, comma standard deviation, sample standard deviation over square root of sample size. So this is the formula. So we need to find the mean, which is the reason for this table. We need to find the sample standard deviation, which is the reason for this. So let's pause the video and complete the table. Okay, for us to, we don't need to pause the video yet. Let's just solve the first one so you see how it is done. For us to get the mean, we need to, mean is given as, x bar mean is given as summation x over n. So this is summation of x, this is x. If we sum all of them, we're going to get 9910.1 if we sum all of them, and what it means is 910.1 over n is 15. So if we divide that, we'll get that our mean is 60.6733, 4 decimal places. So this is how mean is gotten. So for us to now fill this table is x minus x bar. So our x is 62.0 minus our x bar. Our x bar is 60. This is average. Mean means average. So 60 minus 60.0 minus the mean will give us that's approximately 1.3267. If we square that value, we'll get 1.7601. So the same thing we will do. So I'll need to pause the video. We'll do this minus the mean, we'll get the answer, we'll square it. This minus the mean, we'll get the answer, we'll square it. So that's what we'll do. So this minus the mean gives us this, squaring we get this. This minus the mean gives us this, squaring it gets this. So that's how we get it. So the next thing we need to get is the sample standard deviation, and sample standard deviation is given as the square root of summation x minus x bar all squared over n minus 1 because it's sample standard deviation. So that's why we say n minus 1. So this will be equal to square root of summation of this person, which is this person. If we sum it up, we get 11.3095. So we write here 11.3095, which is over our n is 15, so 15 minus 1. So our standard deviation is the square root of 0.8078. So our standard deviation is 0.8988. So these are standard deviation. Now I will need to turn over. Now remember that we were asked to get the 95% confidence interval. And for us to get that, it is 1 minus 95%. That's the formula for confidence interval, which is 0.05. Another means way you can do that is you can say 100 minus 95. It will still give you that in percentage. If you convert that percentage, which is 5, if you convert 5%, it will give you this. So since a confidence interval is always alpha over 2, that's two-tailed test. With two-tailed test, alpha, this is our alpha, we say 0.05 over 2, which will give us 0.005, which was how we were able to get that this plus or minus is equal to t 0.005. That's how we got the 0.005 bracket n minus 1 into standard deviation over square root of n. So our mean that we calculated is 60 point something. Yeah, 60.6, 60.6733 if I'm correct. Yes, 60.733. Then plus or minus our t, we need to go to the table, t table. So the t table, what we're looking at is t 0.005 under n minus 1, which is 15 minus 1, 14, degree of freedom, 14. Into our standard deviation, we got it to be 0.8988 over our n, that's square root of 15. So 60.6733 plus or minus, if we go to the table, t table, this is t table, we are looking for 0.005 under 14, 0.005 under 14, this is 14, 0.005 under 14, what we are getting is 2.977. 2.977. So the 2.977. If we resolve this place, we get 0.2321 thereabout. So we now do this. This might multiply by this, which will give us. If we multiply this out with calculator, we're going to get 0.4990. So we do this plus this, which will give us 60. This minus this, first of all, will give us 60.1743. This plus this will give us 61.1723. So this is the 95% confidence interval. So number 2A says, outline the important steps involved in statistical hypothesis testing. The first step is state the hypothesis, that is the null and the alternative hypothesis. The second step is state the level of significance, alpha. The third one is choose appropriate test statistic. The fourth one is determine the critical value. The last one is state your decision and make your conclusion. The next question says, in a survey, 6,598 out of 21,250 males and 6,147 out of 22,852 females were found to be alcoholic drinkers. Do the data provide sufficient evidence to conclude that the percentage of male alcoholic drinkers exceeded that of their female counterparts. Now, for us to solve this, we state out the first value given to us, x1, is 6,598. Now, the second value, x2, given to us from male is, let's say, 6,147. Now, the total value for the male, they are 21,250. For the female, they are 22,852. Now, the first thing we need to do is to state the H0. Our H0 will say that percentage of male alcoholic drinkers doesn't exceed that of the female, because this null hypothesis is a hypothesis of no difference. It always agrees with the question, so it's a hypothesis of no difference. So you can watch my video on hypothesis testing to understand better. So because of that, the H1 alternative hypothesis will say that the percentage of male alcoholic drinkers exceeds that of their female counterpart. Because of that, it is a one-tail test because it points direction. For more clarification on this question, please see my video on hypothesis testing. So the next step is to state the level of significance, alpha. The level of significance given to us was 5%, which is 0.05, 5 over 100. So the formula we're going to use is that P1 minus P2 all over all square root of P into Q1 over N1 plus P into Q, or we can use just P and Q over N2. So P is the probability of success, Q is the probability of failure, and Q is given as 1 minus P. So because of that, for us to get P1, our P1 becomes X1 over N1, which is 6,598 over 21,250. If we do that, we get 0.310. This is the probability of success for the first one. For the P2, we'll get X2 over N2, which gives us 6147 over 22,852, which will give us 0.2689. I need to turn over. So for us to get the value of P, our value of P is X1 plus X2 over N1 plus N2, which is 6598 over 21250 plus 6147 over plus 22852. And if we resolve that, we get 0.28899. So our Z calculated becomes 0.3105 minus 0.26899 over square root of 0.28899 into 1 minus, that's P, and Q, 1 minus P, that is Q, 0.28899 over N1, which is 21250, plus 0.28899 into 1 minus 0.28899 over N2, which is 22852. So our Z calculated is equal to, the up becomes 0.04151 over square root, the down is 7.4588 times 10 raised to power minus 6, plus this other side is 6.9359 times 10 raised to power minus 6. So if we resolve that, we're going to get that the down part becomes square root of 1.43 0.95 times 10 raised to power minus 5. So this is 0.04151 over the square root of this is 0.00379, and if we get that, finally what we're going to get is 10 points, is it 5? Okay, 10.9525. So the answer is not supposed to be in a mutilation, it's supposed to be neat enough. So the next step is for us to determine the critical value, having chosen the appropriate test statistic, which is the z-test that we've calculated because n is large. So we determine which is z tabulated critical value, and it's going to be z 0.005, which is 5%, and the value for that is 1.645. We get that from the table. So the next one is to take decision, compare the two values. We can see that this is greater than this. So our decision becomes, since z calculated is greater than z tabulated, we reject H0 and conclude that the percentage of male alcoholic drinkers exceed that of the female drinkers. The next question says differentiate between correlation analysis and regression analysis. For us to differentiate that, correlation analysis measures the strength of relationship that exists between two variables, that is x and y, while regression analysis is focused on how one variable affects the other. The second difference is that we use correlation for a quick and simple summary of the direction of strength of the relationship between two variables, while regression is for predicting and optimizing, or to explain a number of response between the variables. The third difference is that the strength of relationship is given by R equal to n summation xy minus summation x summation y all over square root of n summation x squared minus summation x squared, or we can put it x all squared, multiplied by n summation y squared minus summation y all squared, while the regression model is given as y equal to a plus bx, where a is the intercept and b is the slope. Now, in the next point also difference is that there is no dependent or independent variable in correlation, while in regression y is the dependent variable while x is the independent variable. So that's the difference between them. 3b says the table below shows the amount of fertilizer in kg, that's x, applied in the corresponding and the corresponding yield in tons y of cassava, that's this. It says fit a regression line of yield on cassava. Estimate the yield of cassava if 25 kg of fertilizer was applied. Determine the strength of the established relationship between the yield and fertilizer. We need to redraw this table, so I'm going to pause the video and redraw that. So for us to fit the regression line, which is the first one, we use the equation that says y is equal to a plus bx. So having put this is the serial number, this is the x, this is the y. So we need to get b, which is the slope. For us to get b is given as, so we calculate b first, and the formula of b is n summation xy minus summation x summation y over n summation x squared minus summation x all squared. So we have b, our n, that's the number of this thing, which is 7 into, we need to find summation x, we need to find x, we need to find x squared and sum it. So we do that. So having gotten the table, for xy means this times this gives us this times this gives us this times this gives us this. For y squared, this squared gives us this squared gives us this squared, and so on. For x squared, this squared gives us this squared gives us, so we now add the total. So get back to the formula. Our n is 7, which is the serial number. They are 7 in number. So the summation xy, it means add xy together, 20016. So we write 20016 minus summation x times summation y. Summation x is 93 times summation y. Summation y is 1423 over n again is 7 into summation x squared. It means add x squared. This is x squared, so 1329. That's summation of this x squared. Add it together. So we've done that. The other x squared means the summation x square it. That's what this one means, which is 93 squared. So if we resolve all of that, this times this is going to give us 140112 minus this times this is going to give us 132339 over the down, this times this gives us 9303, then this other side gives us 8549. If we resolve this minus this minus this and divide, we're going to get 11.885 as our B. Now we need to get our A. Our A, if we make it subject of the formula, becomes y minus bx. Y minus bx. Since y is many, x is many, from this thing, we can transform it and say A is equal to y bar, which is the mean average of it, minus b x bar average of it. And remember that we can rewrite that this is, for us to get the mean, is summation y over n, minus b is, for us to get x, is summation x over n. So if we fix the value of that, summation y is 1423 over n is 7 minus our b is 11.885 into summation x. Our summation x is 93 over 7. So if we do the whole of that, we're going to get 45.3852. First of all, divide this, multiply out first. When you multiply out first, then you now subtract because of odd mass. So this is our A. It means that the formula that A is equal to, y is equal to A minus bx can now be written as y is equal to, the value of our A is 45.3852 plus our B, because our B is, plus A plus bx, plus our B is 11.885x, A plus bx, so A plus bx, that's it. The other question says estimate the yield of cassava if 25 kg of fertilizer was applied. Remember, they told us that the amount of fertilizer kg is x. So what they are simply trying to tell us is what is the value. They are trying to ask us what is the value of y when x, which is fertilizer, when x is 25. So what is y? What is yield? Yield is y. What is y when x is 25? So we use our formula that says that y, yield, is equal to A plus bx. So y is, the value of our A is 45.3852 plus 11.885. Our x now is 25. So we multiply out, and when we multiply out, we're going to get 45.3852 plus If we multiply this, we'll get 297.125. So if we add that together, we'll get 342.5102 tons. The next question says, determine the strength of the established relationship between between the yield and fertilizer. Okay, whenever we hear strength, we're talking about coefficient of correlation, R. So for us to do that, we use the formula that strength of relation, that's correlation, is given as R equal to N summation XY minus summation X summation Y over square root of N summation X squared minus summation X all squared times N summation Y squared minus summation Y all squared. So we need to prepare a table for Y squared. Okay, we already have that, so we need to now fix the value the same way we did for the regression. Is still the same way. So we have that R is equal to 7 times 20016 minus 93 into 1423. Still, this area is still the same thing that we've done. The only thing is that we're now adding this other part to it. So we have 7 into 1329 minus 93 squared into 7 into 303305 minus 1423 squared. So if we resolve all of this part, find a square root, then multiply, and everything will get set. For the top, we'll have 7773 over square root. If we resolve this side, we'll get 755, I beg your pardon, 755 times 98206, and we'll get all of this and the square root. We get 8610.7799. So finally we'll get that R is equal to 0.9027. You can see the value of R must not exceed 1. It must not exceed 1. So it's from 0 to 1 or minus 1. From minus 1 to 1. So minus 1, you cross, get to 0, cross, get to 1. It must not be less than minus 1. It must not be greater than 1. So since it is close to 1, it is a very strong positive relationship. That is it. A very strong positive relation because it's very close to 1. The next question says, distinguish between type 1 and type 2 errors in statistical hypothesis testing. Now, for us to do that, the answer is that type 1 error is committed if we reject the null hypothesis. Null. If we reject the null hypothesis when it is true. And type 2 error is committed if we accept the null hypothesis when it is false. The next question says, state the basic principles of a biological experiment. The answer is factor level, sample sizes and replicate, blocking, treatment, measurement of response, randomization. The next question says, outline the advantages of any two experimental design plans in a biological experiment. The two biological designs in biological experiments that we want to talk about, the two experimental designs are, the first one is adaptive design. This design, the advantage is it is ethical and allows for a trial for ineffective or toxic treatments to be stopped partway. The second advantage is that trials are more efficient, which maximizes the use of materials, time, and energy. The next question says, two random samples are drawn independently from two normal populations with the following results. Sample 1 and sample 2, sample sizes 16 and 20, sample mean 260, 210, standard sample standard deviation 45, and this. So the first thing we need to notice here is that the sample size is small, it's not up to 30. So because of this, we're going to use the z-test, and what they give to us is also sample standard deviation, not population standard deviation. So what we're going to use is the t-test. So the question now is, at 5% level of significance, test the hypothesis that there is no difference between the two population means, assuming the two populations have equal standard deviation. Don't neglect this last there. They said assuming the two population have equal standard deviations. Now what it means is that, what that statement means is that sigma 1 squared is equal to sigma 2 squared, and we're going to see the meaning of that statement. So for solving, the first step in testing a hypothesis is to state the hypothesis. So null hypothesis will say that the first population is equal to the second population mean. So first population mean equals second population mean, and the alternative will say that they are not equal. And since they are not equal, it means that it can be greater or it can be less. Because of that, it is a two-tailed test. So the next thing is to state the level of significance. Our level of significance, they told us, is 5%, which is 0.025. Since it is two-tailed test, we'll divide alpha by 2, which is 0.0. Which is this is 0.05. 0.05, which is 0.05 over 2, which gives us 0.025. So the next thing is to choose appropriate test statistic. We've already said we're going to use the t-test. The reason is because the population sizes are small, 16 and 20. So the formula we're going to use is x bar 1 minus x bar 2 over, well, since they told us that the population standard deviation of two of them are equal, we're going to use what we call pooled variance, SP, pooled variance, and we'll now say 1 over n1 plus 1 over n2. And pooled variance is given as, pooled variance, the formula to get it on its own is n1 minus 1 s1 squared plus n2 minus 1 s2 squared. S is standard deviation, so n1, that's the first population size, plus n2 minus 2. So if we fix the values, the n1 is 16 minus 1. The standard deviation, sample standard deviation of the first one is 45 squared, plus n2 is 20 minus 1. Second sample standard deviation is 38 squared over, we have 16 plus 20 minus 2. So our pooled variance is equal to 1700.32. So if we bring that to the answer, T calculated is, the first mean, sample mean is 260 minus the second population sample mean is 210 over square root of SP is 1700.32 into 1 over n1 is 16 plus 1 over n2 is 20. The next thing is to press calculator. We'll have 50 over square root of 1. After everything there, we'll have 191.286 approximately, which is 50 over 13.8306, which is, that T calculated is 3.615. The next thing is to get T tabulated, which is critical value. T tabulated is T alpha over 2 into degree of freedom. Our degree of freedom now is this, n1 plus n2 minus 2. That is this, n1 plus n2 minus 2. That's the way to get V. n1 plus n2 minus 2. And when we resolved that, we got 34 16 plus 32 minus 2. This 36 minus 2, so 34. So this thing can be 34. So this can be rewritten as saying t alpha over 2, we got it to be 0.025 in under 34. You can see 34 is greater than 30, so we're going to look for it under under z table. We're going to look for it under this. So under this, so we have that if we check it under the table, we'll have that it is 2.032. We now make a decision. For us to make decision, we compare this and this. You can see this is greater. So our decision is, since t calculated is greater than t tabulated, we reject h naught and we reject the h naught and conclude that this is greater than this. So the next question says, the table below shows the water consumptions of 16 chickens measured while they were taking part in an experiment involving 5 different diets. So this is the table. It says, can it be concluded that the average water consumption of the chickens fed with 5 different diets are equal? So this is under Anova, analysis of variance. So the first thing we need to do is to prepare this table again, and then so having prepared the table, so we add them. If we add this is what we get. We add here, this will get 25. We add here, we get 23.4. We add here, we get 20.4. We add here, we get 20.2. If we add all of them, the total will get 125.2. So we can also add their squared, which is the square of this plus the square of this plus the square of this plus the square of this, and if we add all of that, we will get 327.9. This, the square of this plus the square of this plus the square of this, will get 208.58. The same here, we'll get 182.94. The same here, we'll get 139.7. The same here, we'll get 136.52. If we add all of them together, we get 995.64. So, if we count all of these, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, our n equals 16. So the first thing we need to calculate is the total sum of squared. For us to get the total sum of squared, which is summation of s squared n minus summation x all squared over n. So which, if we add the summation of this 995.64 minus the summation of this 125.2 over n is 16. Either you use small letter n or you use capital letter N, they are accepted. Okay, n is 16. This is, sorry, the bracket is only for this, not this. So if we calculate that, we're going to get 15.95. That's our total sum of squared. The next thing is to get treatment sum of squared. For us to get that is summation x1 squared over n1 plus summation x2 squared over n2 plus summation, we have 5 of them. We have 5 of them from the question here. We have 5 of them, which is 1, 2, 3, 4, 5. So we get to summation x5, summation x5 all squared over n5 minus summation x over n all squared. So For here now, what we'll do again is to, so this one is 32, this one is 25, this one is, the third one is 23.4, the fourth one is 20.4, so we need to write them down. The first one we're dividing by 4 because the rule it has is 1, 2, 3, 4. The second one we're dividing by 3 because the rule it has is 1, 2, 3. So this one will also divide by 3, this one will divide by 3, this one will divide by 3. So having fixed that, the treatment sum of squared is 13.5 if we resolve this. The next one is error sum of squared. For us to easily get error sum of squared, it is total sum of squared minus treatment sum of squared. So which is 15.95 minus 13.5, which gives us 2.45. So the next thing to do is to draw our Anova table. The source of variation, for the first one we have treatment sum of squared. So the treatment, what we got was 13.5 and we got error sum of squared, which was 2.45. The total sum of squared was 15.95. You add these two, you get this. So for us to get the degree of freedom, the first one is for treatment of squared, treatment sum of squared is rule minus 1. If we counted the rule, they were 5. 5 minus 1 is 4. So 4 is what will be here. For error, it is the number, how many they were, minus how many rules. The number n was 16. The rules, how many rules was 5. So 16 minus 5 gives us 11. For this one, is how many number minus 1? 16 minus 1 is 15. Or we add this and this to get this. For us to get the sum of squared, for treatment mean squared, for us to get the mean square, treatment mean square is, we do this 13.5 here divided by 4. So 13.5 divided by 4 gives us 3.375. So we register it here, 3.375. For us to get the error mean squared, error mean square is 2.45 divided by 11. It will give us 0.223. So what we write here is 0.223. For us to now get the F ratio, which is the Fisher test, F ratio, we simply do the treatment divided by the error. So which is 3.375 over 0.223, which is equal to 15.1345. So this is the calculated F calculated. We now need to find the F tabulated. For us to find F tabulated, remember it's 0.055% into 4,11. So the first degree of freedom is 4. The second one is 11. So from the question paper, the values, the critical values were all given to make it easier. So you can see the values that we've been using. They are there. So we can, for 4 under 11, Fisher test is always one tail test. So 4 under 11, 0.05. We will not use 4 under 11, 0.025. No, this one is for two tail test, and Fisher test does analysis of variance, Anova. It doesn't have two tail test. It's always a one tail test. So the value we're going to use is 3.36. So this value is 3.36. We now compare it. We can see this is greater, and since F calculated is greater than F tabulated, we reject the null hypothesis, and the null hypothesis here is always that all means are equal. So we ought to have stated that before solving. All means, so mu1 equals mu2 equals mu3 and so on, while this will say that mu1 is not, all means are not equal. and so on. So since this is greater than this, we reject the null hypothesis, we reject this and accept this and conclude that all means are not equal.